Have you ever imagined automating text translations and generating realistic voiceovers in multiple languages, all powered by cloud-based AI? Well, that's exactly what we're going to show you today. In this video, we are combining Amazon Translate and Amazon Poly to build a smart application that can translate any text and convert into natural sound speech in MP3 format. It is a powerful integration for creating more accessible, multilingual, and productive digital solutions. And to walk you through all technical steps, I have brought in Herbert Pereira, who is going to lead this hands-on lab with you. Stick around. By the end of this video, you're gonna see a fully working app and plenty of real-world ideas to apply in your own projects. Let's dive in.
Just as important as mastering artificial intelligence services individually is knowing how to intelligently combine and orchestrate them strategically to solve real-world tasks and everyday challenges. I am Herbert Pereira, and in this video, we are going to explore a powerful integration between two AWS artificial intelligence services, automatically translating text using Amazon Translate and generating realistic audio in MP3 format using Amazon Poly. So get ready to see an intelligent and practical application that combines multilingual accessibility with enhanced productivity and real-world value. The practical applications and use cases for this solution include the development of spoken tour guides, language learning applications, and interfaces with multilingual and voice support, enabling a more inclusive, dynamic, and interactive user experience. So it is going to be a very cool and hands-on laboratory. To reproduce this lab, we will need to create an EC2 instance workstation virtual machine on AWS to run the necessary Python commands in a controlled environment. In order for the virtual machine, EC2 instance, to have access to the Amazon Translate and Amazon Poly services, it will be necessary to create a personalized permissions policy, a specific role, and associate it with the instance known as instance profile. The entire process of creating and configuring this instance will be carried out via the command line AWS CLI. OK, from Policies, click on Create Policy. This step is essential to ensure that our virtual machine EC2 instance has the necessary permissions to access the required AWS services. This will allow us to paste a custom policy document with precise access control. First, select and delete the default content in the JSON editor. Then, paste the custom policy JSON that grants access permissions to both Amazon Poly and Amazon Translate. Once the policy content is in place, click Next. The next step is to name the policy we're creating. Next, we'll carefully review the permissions it grants, specifically access to the Amazon Poly and Amazon Translate services, which will allow our application to convert text to speech and translate content dynamically across multiple languages. After this check, simply click on Create Policy to finish creating the policy. Once we have our policy created, our next step is to create a role, attaching it to this policy. A role allows trusted entities like EC2 instances to perform actions on our behalf. To do this, click on Roles, then click on Create Role. The entity type will be AWS Service and the use case will be EC2, which is exactly where we are going to deploy this role. It is going to become an instance profile, which allows the EC2 instance to assume the role and inherit its permissions. Our next step is to search for and select the policy we have just created, ensuring our EC2 instance has the proper permissions to perform its required tasks. Select the policy you created and click Next. Now we need to give this policy a name. Once you enter the name for this role, you will notice that it represents the identity or persona that a user or service can assume. Once you enter the name for this role, you will see that it will have the function of taking over this role with the permissions that have been granted in the policy. Click on Create Role. For the EC2 instance provisioning step, we will use AWS Cloud Shell as it provides a convenient browser-based command line environment with pre-installed tools. This allows us to execute the necessary commands directly from the terminal. In addition to being launched with the associated IAM role via an instance profile, the EC2 instance will also be configured to automatically install the essential tools required to create a Python virtual environment during its initialization. This setup includes installing pip, the Python package installer, which will allow us to manage and install all necessary libraries and dependencies for our application within the isolated environment. So, to accomplish this, we're going to run a command that will create a file called installpython.sh, which will serve as our installation script. If we run a command to list the files and then display the contents of this file, we'll see that it contains a bash script designed to install both the Python virtual environment tool and pip, the Python package installer, which are essential for isolating project dependencies and managing application libraries efficiently. In fact, the script will install both pip and the virtual environment tool, allowing us to create an isolated environment where we can run our application and install all the required libraries and dependencies. And now we are going to run the command that creates an EC2 instance, although in fact it has already been created. Let us go back and review each parameter used in this command. The AWS EC2 run instances command will launch an instance using the Ubuntu image. The number of instances will be set to 1, and the instance type will be T2 medium. The SSH key is one that I've already created and saved in AWS. It's very easy to generate a new key pair directly in the AWS console. Just make sure that whenever you create a key, you choose the PEM format. The EC2 instance will be associated with the default security group and provisioned with a 30 GB EBS volume adhering to the AWS free tier limits. Keep in mind that T2 Medium is not eligible for the free tier. Use T2 Micro to avoid charges during testing or learning scenarios. As for the name of the EC2, it will be TCB Workstation. And for the instance profile, it is associating the role we have created. We must enter exactly the same name as the role we previously created. This role has an associated policy which defines the necessary permissions for the EC2 instance to access AWS services, specifically Amazon Translate and Amazon Poly. And now we have user data, which is precisely for executing our script. That said, I'm going to press the Q key to exit. Let's clear the screen. We can close the Cloud Shell. And if we refresh here now, we'll see that we already have an app and running instance. To connect to this instance, you may be connecting directly from the console. You'll get the option. You see that the user is Ubuntu, so click Connect. If you click on SSH Client, you get an SSH command that you can use to connect to this instance. In my case, I'm going to use VS Code. So I'm going to make the connection here, and I'll be right back. I'm using VS Code with the Remote SSH extension, which once installed adds a Remote Explorer panel to the interface, allowing you to easily manage and connect to remote SSH targets. Then you can connect to your EC2 instances and use the best of VS Code, which means you can use the IDE to edit your code, and it will be very interesting. Note that in addition to the SSH connection, we have access to all EC2 files. Let's list the files we currently have in this instance. Let's list the hidden files. You will see that they are the same files. This way we can edit our files with VS Code. If you want to learn how to use this VS Code extension and how to install and configure it, leave a comment and we'll create a video showing you step by step how to install it. Okay, now let's move on. First, I will show you the version of the operating system I am using, precisely Ubuntu 24.04. Our next step is to create a virtualized environment so that we can run our application. To do this, we'll use the virtual environment module, giving it a name, and it will create this environment. If you list it, we now have a folder created. And if you list the contents of this folder, you'll see that we have the binaries. Inside the binaries, we have a script to activate this environment, which will be our next step. Once you run this command and activate this environment, you'll notice that you're now inside a virtualized environment. Our application will need two libraries, Boto3 and Streamlit, to interact with AWS services and create a web-based user interface. Once we are inside our virtualized environment, we can run the pip command to install these two libraries. Boto3 is the official AWS SDK for Python that allows us to programmatically interact with services such as S3, EC2, Amazon Translate, Amazon Poly, Amazon Comprehend, and many others, enabling automation, integration, and custom workflows through code. With Python and Boto3, we can easily interact with AWS services. In addition, we'll use Streamlit, a powerful Python library that allows us to create interactive and user-friendly web interfaces quickly and easily, perfect for front-ends and cloud-based applications. Now let's create the application's code file, which is written in Python and uses Amazon Translate and Poly to automatically translate text and convert it into speech, enabling real-time multilingual audio responses. Now, let's load the application's source code. As mentioned, it was developed in Python and leverages Amazon AI services to automatically translate input text and convert it into speech, enabling seamless and dynamic multilingual communication. At the beginning of the code, we import the Streamlit library, already installed as a prerequisite for building interactive web applications. In the script, it is referenced using the alias C. which we use to access built-in features for UI elements and layout. For example, we use est to set the page and application titles. We also import the Boto3 library to interact with AWS services through API calls, as previously explained. Finally, we import the unique identifier library to generate unique identifiers useful for naming files, tracking sessions, or avoiding data conflicts. As one of the application's objectives is to generate files, we will need to generate these files with a name. So it will always generate them with a unique name. Using this library, uwid, and the OS library is for interacting with files with the operating system, creating, deleting, and renaming. The application will also provide sample text in Portuguese, English, Spanish, French, and German to test translation and speech synthesis across multiple languages, enabling users to evaluate pronunciation in real-world scenarios. This means the application already includes predefined text examples, making it easy for you to test its functionality right away without needing to input your own content. A little further down, we'll also have voice options in different languages. We'll have 3 voice options. For example, in Portuguese, we'll have Camila, Victoria, and Ricardo. In French, we'll have Celine, Leah, and Matthew. The application is user-friendly. Below, we see the instantiation of service clients like Amazon Translate, which enables language translation within the app. Once the Translate client is instantiated, we can invoke functions such as Translate Text, which translates text from a source to a target language programmatically. In the Translate a Text Modes function, the input text and source language are required. Here, the source is set to auto, allowing Amazon Translate to automatically detect the input language before translating it to the target language. This simplifies usage when the source language is unknown or varies across requests. You don't need to identify the input text's language. Amazon Translate will detect it automatically. However, you do need to specify the target language, which tells the service which language to translate the text into. In the same way, we are also instantiating the Amazon Poly client, which will be responsible for audio synthesis. In other words, it will convert text into speech, generating an audio file that can be downloaded in MP3 format and played back within the application or saved for later use. Basically, this is how our application works. Now we're going to run and test it locally in our development environment. Clear the terminal, navigate to the appropriate directory, and execute the command that starts our application in the background using the correct environment and necessary parameters. Remember that we can use Python as a module to run this application. I prefer to use Streamlit Run by entering the name of the file in the terminal, and it will automatically launch the web-based user interface for the application. To access the application, you can enable port 8501 in your security group and access it via this link. Here in VS Code, since we are running our Streamlit app locally, it already gives me the option of accessing it through a local preview in the browser. Let us click here and test our application. Let us wait for the application to load completely. Let us now explore the functionalities and interact with the interface. I'm going to choose a sample text written in French to test our application's translation or summarization capabilities, both extractive and abstractive. For this demonstration, I'm going to choose English as the target language so we can translate the French text and verify and validate the output. Once you've selected your preferences for language, voice, and translation settings, let's go ahead and click on Translate and Generate Audio to check out the result in the chosen language and voice. This is fantastic because as well as understanding artificial intelligence and combining its services, it's also very important that we learn how to solve problems, errors. So why am I getting this error here? It says it couldn't detect the dominant language of the text. I entered a paragraph, but the system can't confidently determine whether it's in French, Spanish, or English. AWS AI Services has the solution for this mission. In fact, our code will also require a third AI service, Amazon Comprehend. This service has the ability to automatically detect the dominant language of a given text, which is essential for us to correctly adjust the translation and speech synthesis process. So to correct this error, we'll need to go back into the IAM policy configuration and make an adjustment by explicitly adding a permission for Amazon Comprehend. So to do that, let's go back to the IAM policy. Search for the name of the custom policy we previously created, access that policy in the IAM console, and we'll need to edit it. Click on Edit Policy to begin making the necessary changes. If you are presented with the visual option during setup, click on JSON to access the structured configuration view. And what are we going to do? We have the poly permission here, we have the translate permission. Here, we're going to insert a comma and paste our permission block code. This is just to give Amazon Comprehend the necessary access. It enables the service to detect the dominant language used in the input text. Click Next, and then click Save to apply and confirm the changes you've made. Now, let us return to our application. First, I will switch back to VS Code to check if there's an issue with the application. We will stop it by pressing Ctrl and C. I'll go ahead and clear the screen so we can run the application again from scratch. This time, I'm going to open it in the browser to simulate the entire user flow from the beginning. I'll also close the previous browser tab to avoid any confusion. Once everything is set, we'll test the application again. So now I'm going to select the German language option from the list. It brings up a sample text written in German. I want this text to be translated into English, and just below I have a few voice options available. I'm going to choose Matthew's voice from the list, and then we'll click on Translate and Generate Audio to hear the result. So note that it translates the sentence into English. Artificial intelligence is changing the way we learn and work every day. In addition to listening to the audio, we also have the option to download this generated file for offline use or sharing. Alternatively, you could choose to save this file and run it later, or simply listen to the audio directly within the application for immediate playback and review. Thank you so much for your attention, and I'll see you in the next video. To wrap things up, I'll press play so we can hear the final result of the translation in action.
Artificial intelligence is changing the way we learn and work every day.
Alright, thank you so much for watching this video, and then if you enjoyed this content, please consider subscribing to our channel. Give us a thumbs up if you enjoyed this content, and then also please leave us a comment telling us what you think about this video and also the things that you'd like to see in a new video here on our channel, okay? And then if you're interested in mastering Move to Cloud, DevOps, and AI with our help, please check the links in the description as well. Hope to see you in the next video. Take care and goodbye for now.